Okay, well, welcome everyone. I'm going to get started. So thank you so much for attending today's webinar on HyperView. As I kind of kick some things off with some introductions, I'm just launching a poll. If you have some time, just feel free to answer the questions in that poll. So great. Thank you so much for attending today's webinar, focusing in on HyperView. My name is Drew Buchanan. I'm the engineering manager here at True Insight. And True Insight is a channel partner for Altair. If you're unfamiliar with who Altair is, Altair leverages decision-making through the use of simulation, HPC, and AI. Specifically, whenever I'm chatting with customers or on a webinar, I always like to bring it to, customers' attention or you guys' attention that not while the focus of today's webinar is on HyperView, we have a number of solutions. So I encourage you, if you do have some type of question, whether it pertains to HyperView or maybe it's something totally different, we probably have some type of solution, whether it's within our portfolio or whether it's within the partner alliance. The other thing I like to point out, if you're unfamiliar with who Altair is, we're pretty much in every single industry with, every single major player. So that's another thing to keep in mind, if you're kind of newer to the tools within the Altair suite. All right, so what's going to be our agenda of today's webinar? So firstly, we'll focus in on what exactly is HyperView, what the background of it is, and how you can utilize it. And then we'll jump into post-processing specifically in HyperView, and then close it out with reporting in HyperView. As I'm going through this, my colleague is in on the chat. So if you have questions as I'm going through the presentation, feel free to send them and he will be able to answer them. And we also save some time at the end with any specific questions that you have. So great. So let's jump into the HyperView interface. So firstly, if you're unaware of what HyperView is a post-processor. And when I say post-processor, it means it's able to look at results for FEA, CFD, and MBD applications. It's a dedicated post-processor, meaning that it can import various result files. One of the really cool things about HyperView is its capability to look at animation and plotting and multiple results visualization. So you see on this image on the screen right here, one of the really cool things, and you'll see as I work our way through some demos in today's webinar, is the capability of layering multiple windows within HyperView, which is something that in other traditional tools tends to be much more laborious, or it's not even there within the environment. One of the other things that's really nice, obviously we're talking about Altair HyperView, but many of you guys may be using another solver and maybe you're using HyperMesh to pre-process. The same license for HyperMesh gives you access to HyperView. So if you are solving with another tool, we can import those solvers directly, and there's a large number of formats that can be brought into HyperView. Lastly, specifically, you have customers that deal in aerospace and automotive that have really specific reporting requirements. The report automation and report template features are very, very nice because they allow you to kind of set up kind of very customizable reports, but they allow you to kind of set up that template and then do it very efficiently. All right, so like I mentioned, obviously, HyperView supports all the Altair file formats, OptiStruct, Radius, AccuSolve, etc. But one of the really cool things about it is we can bring in various file formats, and pretty much every other major tool out there we can bring in directly into HyperView. So you kind of see ANSYS, Abacus, Nastran, et cetera, we can bring those in. But we're not limited to just FEA, so not just structural analysis, we can also bring in CFD. So that's something else that can sometimes be somewhat tricky to post-process depending on the tools you're utilizing. We can bring those in accordingly. And then also MBD, so that would be rigid body dynamic applications. One of the other things that's really nice about the environment is you can have multiple results files. So you kind of saw in that image before where we had multiple windows, and you'll see that as I step into the tool, where you can actually look at different load configurations or different models and very visualize what's happening very efficiently. And kind of one of the other cool things is that models can be overlaid. So maybe you have one case where you're deforming it by maybe 100 pounds, and another case by 200, and you want to see an overlay effect. You can do that very easily within the HyperView environment. All right, so before we jump into the tool, I just want to kind of illustrate what happens within the actual ribbon. So HyperView actually has 3 specific tabs that pertain to actual post-processing. So there's the primary one, which is results. The results tab has kind of the plot features, which would be your typical contour, a vector, tensor, deformation, isoplots. And we'll get into that as we kind of work our way through this. But then there's the query features, which this is kind of one of the big powers of HyperView. Specifically, we can kind of create derived expressions. Prior to entering the reseller space, I spent a large bit of time in the energy industry as a design engineer. And a lot of those times we had specific code requirements that weren't just traditional stress, like von Mises stress. We'd have specific ASME code requirements. By using HyperView's expression builder, we can actually visualize those results directly. So if you're using any specific code requirements, maybe you're in the energy industry, defense or automotive aerospace, you can actually kind of create some custom results plots very easily. As well as querying and advanced querying, which we'll show. And then lastly, when you're dealing in a dedicated post processor, you want to actually be able to kind of create some nice annotations. So typically, if it's a large assembly, you might want to create an exploded view. Maybe you're dealing with axisymmetry, meaning you had something with symmetry boundary conditions. You could visualize the full 3D model. You can do that in HyperView. And then as well as custom renderings or notes, what have you. The other thing to keep in mind, there's a couple other ribbons. There's some advanced tools. You kind of see on this tool picture, you can, if you're familiar with HyperMesh in terms of masking, applying specific entity attributes, and then also kind of collaborating with, kind of see extracting some forces from ANSYS. So there's some advanced tools features built into the environment. All right, so let's actually jump into the tool and take a first look at the interface. All right, so I'm gonna hop out of my slide deck here, and let's first just kind of jump in and visualize the results. So the first thing you'll note, HyperView is built into the HyperWorks framework here. You can kind of see right here. You can change this to HyperMesh if you want, but we're going to be working within HyperView. And then I'm going to open up a model file. So a model file pertains to the specific, in this case, we're looking at a structural analysis, the actual finite element model. So I'm going to specify the finite element model right here. So model.fem. FEM is an OptiStruct format if you're unfamiliar with that, but obviously if you're dealing with an Abacus or ANSYS or external format, you could bring that model in. And then our results file, which I'm going to deal with, let's make sure I grab the right results file, is an H3D, which is the default OptiStruct format, either H3D or the OP format. We can bring those in. So hit apply. And let's kind of get familiar with the interface here and kind of start taking a look at some features here. All right, so a couple things that are pretty nice about the environment. So firstly, if you're using HyperMesh, HyperWorks, the mouse controls are all similar to what you're using on the preprocessor. You can customize those if you want. You can go to preferences and change your mouse settings if you want. But that's one of the other things that makes the continuity nice in terms of going from one environment to the other. We can kind of see down here our actual views. And one of the things I typically like is to turn on my mesh, which tends to be very nice and handy when I'm looking at results. So when I take a look at this case, you'll see right here, it'll tell you where you're loading the model from, and then it's going to actually tell you, what type of analysis it is. In this case, it's a static analysis, and if there's different load cases. So maybe you're dealing with a dynamic analysis or an explicit analysis where you have multiple load steps. And I'll actually show you a case later where we actually have a dynamic analysis where you have multiple, time iterations. You'd see that under here with the different time iterations, which is nice. So as we go to the kind of the entity tree right here, we can see, all the different values in terms of how many assemblies there are, the components, and then even your specific result styles. All right, so let's kind of start going through some basic post-processing. So the first thing we'll see right here is we kind of work our way from left to right, is we have our contour plot right here. And this is actually, we'll actually have all of our results based from, whatever output requests we specified in our analysis. So in this case, we have our element stresses, in this case, von Mises, but you can kind of see various other stress results there. If I hit apply, it's going to show the entire system because it was defaulting to the one component. But one of the cool things we can do, there's a lot of kind of cool ways we can kind of look at results here. One of the cool things with kind of the change in the interface here is I can really easily select components. So for instance, if I change this entity selector in the main window to elements, and then maybe I just want to grab these and then specify I, which isolates, or you could right click and hit isolate. If I create a contour plot now and hit apply, it's just going to show everything there. I could also do this another way, which I'll show real quick. So let's clear the plot and hit A, make the whole model again. And maybe I just want to do it from the element selection here within the actual plot. We can do that as well. And then I can go to the selection here, and maybe I want to go by a window. So those of you who've used HyperMesh for a while, this probably looks fairly familiar. I can do a window select here and hit add, and hit return, and then apply. So this actually allows you to see the full model, but it doesn't have some of the other elements shown. So it's another kind of cool way of being able to post-process, which is pretty nice. One of the other things that's really nice is I can actually edit the legend here. I think default in HyperView, it's set at 9 in terms of the level. So you kind of see right there. I typically like 11, so that's typically what I set my levels at. The other thing that's really nice about this is you can put in a custom header, so you can put your company header in. So if I hit apply, you'll see how it adds, True Insight, the company I'm at. But you can kind of change that and also kind of change the specific precision you want to utilize within the environment. So all these things are customizable, which is very nice and handy. Great. So let me clear this plot. So another really cool thing about HyperView is its capability to have multi-window visualization. So specifically here, one of the things that I'm typically always doing in HyperView is I'm kind of layering windows. So you see at the top right here, it gives you options, a lot of different options right here. So I'm going to go to right here, go to the second box right here. And you'll see it kind of creates another window. And the cool thing about this is I can load a different model. I could load the same model if I want, but in this case, I want to load a different model because when I'm trying to do a design review, probably a lot of you guys are running an analysis and maybe you're kind of changing some boundary conditions, or maybe you're changing some geometry conditions, maybe you're changing the thickness, and you want to visualize what's happening. So if I go here and I'm going to load this other model here, and let's actually just kind of create some quick results real quick, hit apply, and then I can go here. And I can go to contour plot and generate this, hit apply. And if I want to show the elements in this plot, which I do, I can do that. And you kind of see right here, there's a big difference. There's 6.01, 60 KSI to 24 KSI. So that's another really cool thing in terms of visualizing what's happening. And I'm showing this from a stress to stress comparison. But if I want, I don't necessarily have to show stress. It could be maybe stress and displacement. I could do a variety of things. The other thing that's really nice about this is I can synchronize the windows. By synchronizing the windows, I can dynamically kind of move my mouse together, and terms of actually allowing it to kind of move together in terms of, you see right here how I'm moving my mouse from left to right. So again, and you start having a lot of windows, and I'm kind of keeping this pretty easy to start, but we'll kind of build our windows out. You might have like 3 or 4 windows, and they're not limited. You could actually have HyperMesh, you could have HyperView, even HyperGraph. that's kind of the power of the HyperWorks interface. It allows you to kind of look at different tools and different windows. Great. A couple other things I'll point out, kind of just keeping things fairly easy. One of the other common things that someone's probably looking for is I want to look at the min and max. So the plot will always show you the min and max showing up in the system. But if I go to the measure icon right here and hit static min max, and I forgot I was active in this window, it's going to show you where the max location is. All right, so that's the max element location that's occurring in the system, which is pretty cool. You also see dynamic. That would be if I had a transient result, if I wanted to look at that. Additionally, I can actually query results as well. So if I go click on the table icon right here, I can just kind of zoom in and look at my element stress, and it's going to tell me that element and then the actual element stress location, which is pretty cool. The other thing that's pretty nice about it is I can click on the advanced icon. And this actually gives me the capability of actually specifying conditional statements, greater than, equal to, less than. So if I specify 40, in this case, I'm active in this smaller window, so let's make it a little bit smaller. Let's make it 10. And then let's change it from components to elements and then hit apply. It's going to grab all the elements in the system that are at that 10 KSI or greater. It's going to give that element ID, the type of element. So it's a really nice way, and you can actually export this table out if you want. Okay, great. All right, so I'm going to hop back into my slide deck here. And actually, I want to show one more thing before we do that in my notes here. The other kind of nice thing, we talked about post-processing in terms of adjusting the legend, but we can also do it by what's known as an ISO clipping plot. So let's actually apply that here. So you kind of see I can move it from left to right. So what it's showing is a value that's currently at 12 KSI or greater. It's going to highlight every single element that's showing. So you kind of saw that within the querying option, but I can move this from left to right, which is also very powerful. If you're trying to make sure you're not at a critical yield stress or critical ultimate stress, you can kind of visualize these results very quickly. And again, we have capabilities of kind of changing the visualization. I haven't made anything transparent, but you can make things transparent if you want within the system. Okay, great. All right, now let me pop back into my slide deck. So I wanted to kind of get you guys familiar with the interface within HyperView. But one of the real powers of HyperView is dealing with kind of advanced post-processing. So specifically, kind of like the example I mentioned earlier, a lot of you guys probably are working in industries or applications where maybe a von Mises stress or principal stress value isn't, you might need some more advanced capabilities. And so one of the really powerful things about HyperView is the capability to kind of create custom expressions. So you can actually create custom mathematical relationships and actually visualize those results. So in our case, I'm actually going to show you an example of looking at a stress difference value and then actually visualizing that graphic. The cool thing about it is because you create these mathematical expressions via kind of conditional statements, they're very easily able to be parsed onto an existing plot. So that means you can actually visualize the plot. So that allows you to do that. And you can also load up multiple results files, which is I'm going to show you. I'm going to show you the one application with the larger stress and then the smaller stress and how we can build those expressions out. The other really cool thing about HyperView is the capability of looking at derived load cases. So derived load cases would be if you have some type of analysis of multiple load cases. A classic example might be a dynamic analysis, which is going to be the example I show you, where you might have like 40 or 50 different increments. And you can actually create a derived load case, and there's 3 different load cases you can actually include. So the first one will be steps. So say in the example I mentioned, you have 50 kind of load steps. You could break that down and maybe only include like 3 or 4 of the load steps and put that in a separate load case. So it's a way of kind of organizing your data. That's kind of the first way. The second would be linear superposition, where you can actually add a bunch of steps together, which I think that's going to be the example I show you guys, where you can actually add maybe some critical steps that you want to include and what that max stress is going to be, or strain, whatever plot you're looking at, by kind of combining those time steps together. And then the envelope option would be if you're strictly trying to look at a lot of data and trying to look at the min and max between the all the time steps. Derived load cases tend to be much more, obviously, if you have multiple load cases, that's where they tend to be beneficial. So if you're doing any type of transient analysis, whether it's heat transfer or dynamic, structural, or CFD, something where there's some type of transient application, derived load cases tend to be very powerful in HyperView. The other thing about it, it's a very easy GUI, and we'll step through how to kind of build these load cases together. It's a very easy way to kind of build these load cases out. All right, so let's jump into a couple examples here, which is going to be pretty cool. First things first, let's kind of clear this out. So a couple other things that are pretty nice. So you'll notice that when I open the model, I'm opening the actual FEM, which is the finite element model, and then the output file. But HyperView actually allows you to save sessions. A session is all kind of the post-processing data. So that's why there's a session and then also a model. I'm not going to start from square one, so I'm going to clear this session data. So it's going to get rid of all these plots. And then I'm going to open up my model. All right, so let's open up the model here. And I want to kind of first start out with kind of that custom expression builder. So we want to actually look at a couple different cases and then kind of create a custom expression. So our results file here is going to be our first value here. And I'm going to make a 3x3 here. So I'm going to go down here and create 3. So there's going to be 3 windows on here. Another thing to kind of keep in mind, and I'll show this in the next example, is you can also create multiple pages. So I'm creating multiple windows here, but you can also create another page. And I'll show that in one of the reporting examples where you can have different pages with different data. So it allows you to kind of have a lot of different results in kind of with only one instance of the post processor open. Now, if some tools, if they don't have a dedicated post processor, what a lot of times users have to do is they have to open up multiple instances of the program, start straining your memory. This is again one of the powerful things about HyperView. Gives you the ability to kind of visualize and look at your results on one instance of the tool open. All right, so let's kind of create and kind of show this custom expression. So I'm just going to look at von Mises stress. This is kind of our first model here. Let's turn on our elements. Great. And now let's open up our second model here. File open. And this is going to be the model which actually has, if you're kind of curious about it, there is actually a there you go. I was active in the wrong window there. If you're curious about it, this is actually, there's a small bearing pressure at the bottom. You can kind of imagine the top is being restrained. So let's kind of create our contour plot. Hit apply and then turn on the elements. All right, so we can clearly see there's a difference between these two. And in a lot of cases, we know that stress, if you're in the kind of that stress strain curve where you're less than yield, in this case, we're less than yield, and there's kind of a linear relationship, but in some cases you might be beyond yield. Stress necessarily isn't linear, and then also maybe you have different load cases, different loadings. You might actually want to actually create a plot that actually kind of looks at the stress difference, between this plot and this plot. So that's what we're going to do in our third window right here. We're actually going to use the expression builder and actually kind of show a nice result that actually has a difference in these stress results. So one of the caveats of it is we need to actually have some type of model so we can parse the data onto it. So I'm just going to start off with kind of the the large stress result, but it's going to change as we kind of build this expression out. All right, and then I'm going to create my stress value here. Okay, all right, so what we're actually going to do in this third window is we're going to create this expression. So I'm going to go to the results here. And remember, the first 5 plots here are all kind of your default kind of plots, you know, vectors, tensor plots, isoplots. And we're delving now into kind of the custom expression building within HyperView. So I'm going to name this. The first thing, the label is going to correspond when we actually create this expression. It's going to populate in the result types. So I need to create a label that represents what I'm going after. So I'm going to name this as stress difference. That works. And then I'm going to add my resource, and the resource is just the results file you're referencing. So I'm going to grab the first, because I'm creating an equation here, I'm going to grab the larger result file. Hit OK. And then I'm going to specify von Mises stress. And it doesn't have to be von Mises, but we're kind of comparing stress. It could be whatever you want. And then external 1, because that's the first resource I applied, and hit insert. Then you'll see right here, here's all the kind of the custom expressions. So pretty much every single mathematical expression you'd want for typical equations, you could kind of build here. I'm just going to do kind of a stress difference. I'm going to hit minus. All right, so now I need to add the second results file. So it's just simply adding the resource. You'll see the resource label is external 2. If I wanted to name it, I could say, you know, whatever the different file is, but I'm just going to say external 2 is fine. And then I'm going to go up here and grab that other results file. For comparing stress, so it's got to be von Mises stress and external 2. Hit insert and hit apply, and then hit OK. All right, so what we need to do now is go to our result type. You'll see that I have this new expression built into the tool, and then hit apply, and you'll see that the stress values changed, and all the element values will reflect the stress gradient difference between these two. Definitely very, very cool, very handy in terms of looking at our results. Another really cool thing about this in terms of some of the advanced post-processing, before I jump into Derived load case, is we can also extract data. Not focusing in on hypergraph today, but it's important to note you can plot all of your data. So let's maximize this window. And by maximizing it, we can kind of see our results very easily. And I can click on linearize. So here's another thing I just want to touch on. One of the key things if you're doing any pressure vessel design is you need to linearize your stress if you have like solid elements. We can do that in HyperView. So if you're doing pressure vessel design, you can linearize it. You kind of see there's a stress linearization method here. But in my case, I'm just going to extract data because I just want to create a plot of how this stress value, or whatever is active in the window, which is stress, is changing across some locations here. So I'm going to specify a path definition of this node to this node. And you'll see it creates the line and it's grabbing everything across that path. And then what I can actually do is hit apply, and it creates a plot. This is kind of a bit, there's a lot of custom plots you can create, and HyperView works in conjunction with HyperGraph to kind of create these plots. But you can kind of see right here where I actually have how my stress value is changing across a set distance. So pretty much everything that you would want in terms of looking at, you can kind of visualize. Another thing to point out before I jump into Derived load case, you could also create a free body definition and look at a free body diagram. So if you're really kind of worried about kind of checking results, you can obviously view your FBDs in the system. And then also there's a hotspot tool. This is actually a relatively recent addition to HyperView. I think like 2 or 3 editions ago it was added. So it actually allows you to kind of look at hotspots or possible locations where there might be a stress singularity. Okay, great. So let's actually look at a derived load case now. So I'm going to, again, clear my session here. And I'm going to in this case, I'm actually going to load a session, which is pretty cool. So you'll actually see I've already prepped a kind of a HyperView model that we can actually open the session. So the session is actually the HyperView file output, and the model is opening the model is kind of what you ran in your finite element analysis or CFD analysis, et cetera. So if I go to open the session file here, grab this derived load case and open up this session file. Hit yes, and you'll see right here. So again, this is an example kind of showing you, there's two windows right here. There's actually a hypergraph. One of the other things that's really powerful about HyperView is its advanced animation capabilities. And you kind of see how the hypergraph is syncing with HyperView right here. I can customize this animation right here in terms of what the frame rate is going to be, where you can start and stop it. So that's another really useful aspect of kind of adjustment here. So here's the frame rate. I can really kind of customize it how I want, but I'm not going to change anything on the animation side. What I want to show is I want to show the derived load case. Okay, so I'm going to click on this main window here. I'm going to maximize it. And okay, so it's showing the stress value. So obviously you can actually animate this, and it's going to show you. You can kind of move it through in and out. The other way of doing this is if you actually go to the time step right here and specify it, and it's going to show you what these results values are. So a lot of cases in very large kind of dynamic analyses, you might have a lot of time steps here. And so this is where the derived load cases can be very handy, because one, maybe you could reduce the number of steps you're including, or in this case, maybe I want to kind of add a couple of these steps together. Maybe I'm just trying to add a factor of safety into the system. So let's kind of do that. Let's go through that. I'm going to go to the derived load case right here. And then you see, here's my three different options. The step option would be if I just wanted to, maybe have a load case of less steps here, but I'm actually going to go to superposition. So what it's going to do, it's going to add all these steps together and make one step. So I'm going to grab a couple time steps here. I'm going to grab this time step here. And this is very arbitrary. I'm going to grab this time step, and then maybe grab this time step. So it's going to utilize all of the results outputs from each of these time steps, and they're going to sum them together. Note, we can actually apply a scale to it as well. So again, this gives you a lot of power in terms of adding safety factors on the systems. Like you could have a multiply maybe your critical value by 2. So you can actually scale these accordingly. I'll rename this as just super as my derived load case, and hit OK, hit apply, and then hit OK. So you'll see now under my load case, you'll see the one I just created, the super. And then there we go. We have our linear superposition plot populating. A couple other things I haven't shown, but also the default, if you don't want to go to the contour plot, HyperView actually kind of creates a bunch of default plots for you automatically. So I can actually go here and click on von Mises, and this is actually applying those 3 steps automatically. So again, it saves you a lot of time in terms of going through this, and pretty much all the default plots are already kind of showing within HyperView, but you can also kind of create your own kind of custom plots accordingly. Okay, great. I'm going to hop back into my slide deck here. And let's jump into reporting. So again, it's impossible to show everything in an hour in HyperView, but hopefully it gives you an idea of some of the power in terms of advanced plotting. The expression builder and the derived load cases is such a great capability within HyperView. It really allows you to kind of zone in on data. Probably the final thing a lot of you guys are aware about is the capability of being able to report values. So we saw the value of that, being able to kind of create our plots, create our contours, but we can also kind of create reports in HyperView. So HyperView's reporting allows users to actually extract session data into typical report formats like Word or PowerPoint, PDF, or even HTML if you want to have an HTML kind of link you can send. One of the really cool things about this is you can also work across platforms and Windows and Linux, which is what HyperWorks is currently supported for. Excuse me. So as far as the actual reporting panel, this is what we'll kind of see in a moment. But I just wanted to kind of get you guys familiar with this before I step into the example. So firstly, the predefined example, there are what's known as a session report, which would be all your active sessions, whatever images are active in the Windows area, it's going to create. So, if you have a bunch of pages or sessions, it's going to, look at whatever's active in the graphical window and then create a report from it. We'll see how it does that in a moment. And then the other predefined, so predefined means these are just, automated reports that are automatically built into HyperView, is the model summary, where you can go off a predefined summary list and it's going to create a report automatically for you. And I'll show an example of both of these. But the real power of HyperView is its capability to actually kind of create template reports. I know I've worked with a number of customers in the kind of aerospace and automotive realm that you have kind of custom reports, how you're building things out. You can actually build a custom report, and we will build a custom report so you guys get a feel for it, and then save those templates and then reload them. So there's a nice way of kind of going about it. So the define ribbon is kind of where you kind of create your report, export it, and then open up templates. The add item is kind of where you kind of create chapters or text captions and where you kind of grab your images. And the module ribbon is nice because this is also the power of HyperView. It actually has it. We pre-built into the GUI how it can read everything you'd want in terms of maybe I want to grab model data from the input solver deck or the mesh data, et cetera. We have all those pre-built. Just an icon we can click. And then there's also kind of what's known as a while loop. We call it a results loop, but it's pretty much, you can specify, I want to create one type of image, and then you can kind of apply it for a large assembly, and it automatically creates all the images for you. And I'll show that as well. But it's a really nice way of kind of being able to automate reports. And if you have a lot of data to post-process, it can do it very efficiently. All right, so let's jump into an example of this. All right, so I'm going to open up a new file here. And I'm also going to clear my session too, because I opened up a session. And then I'm going to open this up. I'm actually going to open a session. I have another session I've opened. And remember, the session is the post-processing data. So that's what we have here. And it's just going to load this. So a couple cool things you'll note as this loads. It's actually going to load, which is pretty cool. If you haven't seen HyperWorks before, it's actually going to show there's going to be 4 pages, which I'll delve into. The 4 pages, the first page you'll see right here, this is actually HyperMesh and specifically OptiStruct. So that's the preprocessor showing on page 1. And you kind of see right here, I can add as many pages as I want. Now, if I click on page 2, you'll automatically see that the second page is set up as HyperView. So this is kind of the model overview. It kind of includes all the steps within the system and everything there. If I go to page 3, you'll see that I've already created some custom plots for you, which actually have kind of the applied forces and the displacement showing up for this airplane wing. And then 4 actually has the composite stresses showing. So I'm going to go back to page 2, and we're going to step through the report options here. All right, so we're going to go to the report tab here. And then the first thing we'll do is we can create a session report. And what we can do is kind of create this. There's not going to really be anything of a ton of value, because there's just kind of showing the main overview of the model, but it's going to automatically kind of create this session report for us. All right, so what I automatically did is I created this HTML report, and you'll see right here, this is just all the active session windows. So that's what's showing here, page 1, page 2, page 3, page 4, and whatever's active in the window. That's all you're going to get from that session report, which is the predefined report. It may be useful to you guys, but Typically, when I'm using the predefined reports, it's generally the model summary predefined report. And let's click on that. And I'm going to change this from HTML to be presentation. So first thing, I can save this to wherever I want. I can save it as a PDF, an ODP, or in this case, a PowerPoint. I'm going to go off of PowerPoint is fine. And I'm going to save it just in this. I'm going to name it as webinar report. Okay. And then if I had all of these, it would actually grab pretty much everything you typically want for most FEA scenarios or CFD scenarios. But it would take some time because this is a larger model. So I'm only going to include these 3 items. Nice thing about it is you can unselect or select them all really quick. But I'm just going to grab these 3. So I'm going to hit export. And this should take about less than a minute. It's going to actually go through and automatically create that data, but it's going to give you a feel for kind of how the predefined reports functionality works. So remember, I have the model views, and I also have a little bit of component data on the mesh that's going to be shown in the report. So once this comes over, you'll see right here, it has all the different views that you can visualize here. The mass data, and then also some model statistics. So all the different types of elements shown in the system. So I definitely, in terms of automated reports, the predefined tends to be very, very nice for most users. But bear in mind, a lot of you guys are doing customizable things, and there's certain things you need in a report. So that's kind of where the power of HyperView comes into play, is we can kind of create a custom report. So that's what we're going to do now. So we're going to create a custom report so you guys can get a feel for it. So I'm going to go to new report, and I'm going to hit no because I want to start from scratch. And you'll see that it first populates right here is the report. I can name what it is, but we're going to kind of work our way through this. So the first thing we'll do is I'll create what's known as a new slide. New slide is going to be one image with caption. All right, so the first thing is going to be the text. I'm going to say this is a report, and then I need this is the text that's actually in what you'll see in the actual report. So I'm going to say wing review analysis. Hit OK. And then on the image right here, it's going to tell you, what image do I want to kind of look at here. So in this case, it's page 2, window 1. So it's going to show whatever's active in the session. So this is page 2. So right here, you see it always gives you the number on the page. And there's only one window on this page. You can kind of see the square indicates one window. If I go to page 3, you'll see right here, see how it shows 2? That's 2 windows. So that's what this kind of designation is pointing to. I will just name this as partial wing. And then you'll see that I haven't actually run or kind of saved this image. That's where this warning symbol is. I have to right click and hit run. That's it pretty quick. And then we're going to kind of build this out, but I just want you guys to get a feel for what I've just created. So if I hit export, I can actually save this report now. I'm going to save it to the folder we've been working in. I'm going to save it as partial report. And once it does that, you'll see right here, wing review analysis. And I think I forgot to change this title right here. So let's change this to introduction. All right, let's resave that out. But you can kind of see there's a lot of nice features in terms of saving things out. So just gonna regenerate that. And there you go. You see how it changed to introduction. I have the name, wing review analysis, and the image here. Okay, great. I mean, it's fairly straightforward, but let's kind of start leveraging and kind of building out the power of this, because this is a pretty large model. For reference, I think there's like 91 different components, like 10 different sub-assemblies. You can imagine if you wanted to create a stress plot for all these different components, it would take a long time. And so that's where we're going to kind of use some of the advanced kind of building within this environment. So the first thing we're going to do is we're going to start adding some modules. So modules, kind of some of the tools or pre-built report functionality built into HyperView. So I'm going to go to model info here. I'm going to specify entity overview. An entity overview is going to kind of lay out, what the actual kind of hierarchy of the assembly is, or entities specifically. I'm going to name this as assembly level 2. Change the entity type to assemblies, and what the level of the assembly is going to be. And then I'm going to right click and hit run. And you'll see that it has all of these images pertaining to assembly level 2. So fuselage, etc. So I'm going to hit capture image because these notes have already been created. So these are notes that I've already generated that pertain to the specific assembly level. Okay. I'm going to go to the report. I'm going to do the same thing. I have another assembly level, which is assembly level 3. So I'm going to go to entity overview. I'm going to name this as assembly level 3, and select assemblies, and then specify level 3, and then right click, hit run. And you'll see that the notes change. So I have all these notes here, and I can hit capture image, and I can close this out. So it's already created the images that's going to be included in the report. When you actually see the report, it'll specify the different levels, which is definitely pretty neat. Okay, great. So let's keep building this out. So I'm going to go to model info. A typical thing, if you're looking at a system, is what your properties are going to be. So I'm going to specify the property summary, which is going to include all the properties of, all of the components I have in my system, which there's a good bit. And then I can also go to the validate tab right here, and this is where I can actually grab the model statistics. So this would be like you saw in that predefined report, all the mesh data, size of the model, et cetera, that would be stored within here. Okay, so let's go to the next, and I think this is really where the power of the tool is the results feature. So if I click on the results module, you'll see that there's these modules right here. So this loop results feature, think of it as a while loop if you've done any coding. You kind of specify, this is the type of result I want, and then you apply the components you want to apply it to. So it means it can kind of automate the entire process without you having to create 10 different, in this case, I think it's like 20 different plots for different components. So if I go click on loop results, it's going to ask you for what ideas, what you want. And I'm going to name this as applied forces and displacements. This is just a label. But the key thing that I'm going to go after is you need to have kind of some designated result that you already created, and that's kind of the purpose of page 3. So I'm going to go to page 3, window 1. And from there, I can specify, click on components. And this is showing the entire system, but what I actually want to do is actually want to look at the actual forces for individual components. So only showing one component at a time. So if I click on the 3 periods, which is the advanced selection here, I can actually grab individual IDs. So just bear with me for a moment. I think you'll kind of see the power of this feature very shortly. Okay, so these are just specific component IDs, and we know in whatever structural tool we have, everyone has a component ID. So that's what these component IDs pertain to. And right here we have our component ID. And then great. So what it means is it's going to then look for each of these components. And and then it's going to kind of go through this loop. But bear in mind, it hasn't actually created any images yet in my report. So I actually then need to add a new slide to do that. The other thing to keep in mind, this is actually under the applied forces. I can also have the loop statement going across multiple load cases. So I can do that as well. This is actually 3 load cases. And so even though I'm only plotting 1 load case here, I can grab the 2 additional if I want. All right, so I've created that load case. And I'm going to add a new slide. So I'm going to add a slide here, and it's going to be 2 images with captions, because we have 2 images here. The first one is going to be, I'm just going to name it as forces. Hit OK. And I'll name this as just force so I know what it is in my result browser here. And then I'll go to here, and this one's going to be displacement. And in here, I'm just going to name it as displacement. Hit OK. And then right here, here's kind of where the power of the tool is. I can specify what window I'm after. I can change this to a GIF, this is a transient analysis. So GIF is actually automatically going to create an animation in my report. If I'm using a PowerPoint, so it's actually going to create an animation automatically for me. So I'm going to do that. And I will name this as forces because it's page 3, window 1. So this is page 3 and this is window 1. So that's what I want. And this is going to be displacements, and name this as a GIF. All right, so once we do that, we've kind of created a report. We could also create another result if we wanted for our page 4, which we can do, but I think you kind of get the idea here. And then once you're ready, you can then actually run the report, and it actually runs it out. So let's open up that report. It takes probably, because there's so much data here, about 4 or so minutes. So, and it's also dependent on what your machine specs, but it took me about 4 minutes. But one of the cool things about it, it's a very large analysis with a lot of animations you'll see. So you'll see right here, this is the report that's generated. And as we start going through this, you see how the initial page 3, it had the entire wing. And this actually has the specific components called out. And here's where the animation is going to play, those GIFs. If there's an animation, it's going to bring them into play. So you see how they're all kind of animating. So imagine trying to create all these plots automatically on your own. This does it just via a nice loop structure, and which is also very, very nice. Page 4, one of the final things I'll point out, the visualization results feature within HyperView for composites is very, very handy. In terms of visualizing composite results, it's definitely something that the tool does very well, versus some other tools can be somewhat hard to kind of do that. So if I go here and go to here, I can show my composite strain. I can show composite stress. Very easy to kind of visualize these results accordingly. All right, so let me hop into my slide deck here. So firstly, thank you all for attending today's webinar. I'm going to kind of save the last few minutes for some questions, but before I kind of start going over some questions, check out our blog and our social. We're always updating our blog with new information very often. Also, our YouTube page, we're putting what's new, how-to guides out there. And also, we are running webinars every single month. I think next month is going to be on PSIM. So definitely keep an eye out, and we'll keep an eye out for that. But I want to thank everyone for attending, and I'm going to take a look at some of the questions. I think there's a couple questions in the chat. So specifically, what's the file format, Stephen, for COMSOL? I believe it does. I would just have to take a look at the file format for the result, but it should work fine. Yep. So I know COMSOL has like electromagnetic, there's a couple different file formats and whatever COMSOL you're working in. Yeah, the other question we have here, good question, Rick, are the number of animation steps related to the solution steps in NL-PARM? Yeah, so the actual steps themselves, they pertain to the steps, but you can adjust the frame rate. So if you don't have a lot of animation steps, you can adjust the frame rate in terms of the interpolation to make it a little bit smoother. But yeah, the animation steps pertain to the NL-PARM steps. Yep. Any other questions? I'll stick around in the chat. I think we have like 5 more minutes left. I want to thank you all for attending, but I will stick around if there's any follow-up or final questions.